Okay, I'm going to start to do a course, or let's say a sharing of what I call a advanced mathematics. And I'm going to be very brief with that. Basically, the content of this is based on what is called master math in the Netherlands. And you can have a look at what is there. We're not going to talk about everything here, but actually there are four tracks, and I merged one track into the geometry part. So it will be a little bit more than what is here. So what are we going to talk about? We're going to talk about three tracks. The first track is probability, and we are going to include something like basic probability, Markov chains, martingales, like stochastic integration, and probability inequality, and so on and so forth. The second part is the function analysis, and I'm using this term very loosely because more or less we are going to divide it into two parts: the geometric part and algebraic part. And also, we will talk a little bit about nonlinear operator. The third part is the most ambitious part. It's what I call geometry and dynamic systems. So we're talking about a lot of things like category theory, Riemannian geometry, both in the finite dimensional case, complex manifold, and based on, say, Banach space and Hilbert space. We are going to talk about algebraic geometry. We are going to talk about representation theory. We're going to talk about random dynamic systems. So it's probably better to call this a track, three tracks. This will be so basically for one track. Uh, Even if you are only using the relatively simple part, it is enough to get the four masters in mathematics in the Netherlands. And you have to understand that these courses are not that easy. And there are something that I want to say. So first of all, this is not a typical course. This is more like a guide for self-study. Because even if, let's say, we're going to talk about probability theory, one of the reference that I'm going to use is Foundations of Modern Probability by Panoramaof. And if I'm going to even write down everything, it's going to take maybe 3 semesters. So we are only going to select more or less the, let's say, the skeleton or the, I don't know what to say, the main body of it. But we'll also be talking about some of the beautiful proofs that you can use. And one thing that I find very hard to do is that I have to use the book. Namely, I'm going to use this pad, and I'm going to use the book and maybe add some kind of notations, some explanation on notes myself. But the most important thing is why I do this is that even if I'm copying everything, it's going to take a long time to do it. So, not very ideal. And my focus is actually quite ambitious. My focus, or let's say my interest, is to understand the interactions between different disciplines. Now, I understand that mathematics is actually huge uh, subject. Uh, Not necessarily because it has the thickest book, but because it has been so specialized that usually it's very often that even if I'm doing probability theory and you are doing probability theory, we do not know what you are doing. That's just how specialized it is. But there is also something that is very important. A lot of very interesting results actually from from people borrowing another subject into here. Like to give you an example, Lucien Lacan. actually made a book called Asymptotic Method for Statistical Decision Theory, and it is very important. And the language he used is functional analysis. And the problem that he wants to solve is actually statistics. So you will say that there's nothing really there that connects each other, and then you'll be wrong. So I will try to kind of focus on the interaction between them. And for the prerequisite, basically, I'm going to have to assume that you are mathematically mature. Uh, so, for example, you might not have learned complex analysis, but if you want to follow this, I assume that you will be able to finish the basic complex analysis of Marston in just several hours, and then you can use it. Uh, and this is called mathematical maturity because if you go to study mathematics, you are going to be forced to learn new areas, new results very fast. You cannot have 100 exercises and then you start to research. That's not usually how it works. One unfortunate consequence is that there is going to be interactions between the tracks. What I mean is that, for example, in probability theory, in the third chapter, we will start to talk about the operator. Now, operator is usually introduced in functional analysis and in the later part of it. But because we don't want to repeat things and we don't want to wait until everything is ready, I will have to ask you to check the operator, the relatively related operator theories by your own. And lastly is that what I'm going to talk about. So basically, uh, although I'm talking about a lot of things, I'm talking about it in an applied way. So basically, two things. First of all, of course, a lot of results that you can use. The second thing, I'm going to choose a sometimes very typical proof techniques that you can use. And in some cases, I'm going to indulge myself in some very beautiful but unusual proofs. So I hope this course is an opening for theory of learning mathematics, and so it is like I try to open the door, and then you can go on to study more monographs based on what you want. Okay, this is an introduction, and see you next time.